Okay, I wanted to make an update on the video I made the other day about maze lambdas because I've been working on them today and made some crazy improvements. So I thought I would kind of show them off since I've been working hard on them, and some of the things they can do are quite powerful and might be interesting. First of all, we have this map here. This is the Bear Island map, and we have a list of things here in the range they can see us from. So the first lambda I showed in the last video was a block out map lambda. That was a little bit slow because I was iterating across every single cell on the map, checking if anything is in range of their sight, and then spilling an X if so, or another fill character. Now I came to the problem when I actually tried this on Bear Island that I needed to know which bear was in my range. So the first thing I wanted to do was to have the default is to spill out the actual character of what's in that cell. So as you can see, that works there. Another update I made is I can fill these ranges into 0 now. So if I press 0 here, you'll see that all these white bears disappear. Also, the map is much faster. So if these black bears could see 7, that's going to be quite intensive calculation, but it's pretty much instant. So that's the first good thing. So let's just up some of the ranges on these bears. Like I said, setting them 0 is great because I can turn things off and on at will, which will come in handy later for the maze lambda, which works hand in hand with this one. So the next thing I have is a fill. So I can still add a fill if I want to, again, because on the maze lambda later that can be useful. I can also specify if there are no diagonals. For example, if these bears could only see up, down, left, right, here's where they can move in their number of steps, so that starts to look quite interesting. And then the final argument I have is a list of custom directions. So these are arrows, and I have a lambda that turns these into movement coordinates now. So I can actually input some custom directions, and that will override whatever I've put in for diagonal or not diagonal. So let's say they can only see in the diagonals, which would be a little strange. But then we can see what would happen and where their sight lines are. We could also change these directions to be, they can see every 2 steps for whatever reason that might happen. But you get the point, it's really flexible. So I'm super happy with that one. So let's now have a look at the maze solver. So if I type equals maze, let's say this is my map, first of all, and I want to do a start cell. So those are the 2 required inputs. So let's say my start cell is let's change it to E27, E27, and we'll see that E27 is now 0, and we spill our maze. So at this point, we're able to walk in all of the blank space in this map. Now, one of the problems I had with this maze lambda is I wanted it to interact with the blocked out map lambda. The first problem is if I didn't spill this map and just had it in this array, so I used a block out map within this, and didn't ever do this intermediate step of spilling it somewhere, then all of the row and column number formulas within the lambda don't really work because there's no reference point of a row and column. So I made that work, and also there's another issue where if you don't spill it, it treats the blanks as blanks, but in something spilled, it treats the blank space as 0. So the default behavior is that if it's spilled somewhere, it will look at all the 0 spaces and move around those, but if it's not spilled, it will use the blanks. So let's just show this off a little bit. So I have this map here. Let's actually start from in the water on E30, just to show you some of the other features of it. So if we start in the water, we're saying we can only move into the blank space. We can also have a target cell, which will we put a cell address in, it will tell us how far it is away, i.e. it will retrieve this number off the map. We can have no diagonals again, so you'll see that the movements change. So I'll just Control Z. You can see from 0, these numbers will change to allow diagonals or not. We also have an allow feature. So if I wanted to allow walking on water, I could say that. So actually, we're allowed to walk on the water. So now we will move along the water. And the reason I've put that allow condition in is because sometimes you might have a path and you can only walk along a path. So if I use a macro to change the map colors into numbers, I can say, okay, you're allowed on number 6, and then it will only run the map from those colors, for example. We also have a block argument, which is the opposite of allowed. So I can specify somewhere where we are not allowed to go. So if I said we're not allowed on water, then we would be allowed everywhere else. So that's the reason for those. You can see if I say we're not allowed on water, it automatically unblocks all of these cells that were previously blocked because we were only allowed to run on blanks. So let's go back to normal. I also have custom directions, a bit like I showed off in the block out map lambda. So I can say, we can only move, I don't know, maybe these ones, which is a weird set of directions. And then we can see we can only actually make it up to this cell in that circumstance. So let's add in maybe a cross arrow here as well. And then you see we can span a lot further with that set of arrows. Again, I can put in any custom directions, not just a singular arrow. So this could be moving 5 cells across, 1 cell across, anything like that would work just fine. I guess the last thing to show you is kind of the default behavior between the blocked out map. So at the minute I'm running off this map that hasn't been touched. If I was to run off the other map, and the start cell would now be AI27, so let's change this to AI27, what you'll see is it works very well with the block out map lambda, and now all of our bears are blocked out quite nicely and the water's blocked out nicely. And then the final most impressive thing, I guess, is I don't actually need this block out map lambda at all. I could just say in one formula block out this map with this table of things, and let's start where we did it before on E30, so that's near the water, and we'll get our map. So there is actually no need for this at all, and we can work directly off an individual map and still block out the characters. So yeah, if we were to block this out with 5 characters, again, we can't actually get hardly anywhere there. 2, 5, let's go back to 2, and then I can turn this bear off by putting a 0 in. So yeah, it's very flexible. A quick demo just to show you the power of this. So on this latest many maps of Merlin case, this was a very hard case. So we had to find Lana, who's hidden, so it's actually in this cell, but you can't see her because the colour's there, and she needs to get to a banana. But there's all of these things blocked out that can see you in this range. So I can put in those ranges there. There's also a brick wall that blocks you on one of the maps, and water. So I've called these BL for blockers. I've called this MQ for Merlin's Quarters, EC, BC. These are spilled earlier just from me playing, but in reality all I need to do is say block out Merlin's Quarters for my blockers, find the address of Lana, because that's my start address. So I've just said, find the address of this character in the map, and then my target cell is where the banana is. And then I can just add that up for each map, doing exactly the same thing, and it will give me the right answer. And just to show you how quick that is, I will press enter. Done. Let's do one final show off in the Bear Island case. This is actually my probably my favourite case of this. I come back to this all the time for maps because it's just a fundamental map case video. So let's change those to water, and then we have our blocker table already given to us in the case here. On this question you need to know like which bear are you in range of. So for that I can just actually copy the map over, delete everything out, and then let's just say block out the map with our table, which was at the top here, and we see that spills nicely. And then to find the bear that was going to steal our food, we can just indirect the map on our cell address, and that would just give us the bear instantly. And we're here, we're not in range of bears, so we'd get the full price for our baskets. Level 5 was the super hard one. This is where we block out the map and we try and find the distance. I mean, this is the one I just showed in the example, so it will be obvious, but just to see it in real life, I'm not going to actually use this map. Let's pretend I didn't spill it nicely for me to work with. I would just say block out the map with the blockers. And I want to move on, I want to do the maze. My start cell I know is E27, and for this one I have a target, which is here, and that should be it, really quick. And what's even another thing I haven't actually shown is this target is will take an array. It will take this whole array of targets and it will spin it down, and that's how quick it is to run this thing. So yeah, I hope you enjoyed this video. I thought I would share my work because I'm proud of it, and I just want to show it off a bit, and hopefully it inspires some other people to work on their lambdas. I'm happy to share these ones as well for people to use them, but yeah, they were very hard to make, and I learned a lot doing so. So thanks a lot, and I'll see you next time.